Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called best time to buy and sell stock. So in this problem we have been given couple of prices, and then these prices we can make at most one transaction, as they mentioned in the question itself, at most one transaction. And this transaction means like we can buy one stock and sell one stock, right, at any given point of the time. So I just copied this array in the whiteboard itself. So let's see, if I purchase this stock at the price 7, these are all the prices, right? So if I purchase this price at price 7 and then if I sell it at 1, then I will get the uh, this is not the profit, but this is kind of the loss I will be getting. Six bucks loss that I will be getting, right? Similarly, everything is lesser than 7, so there will not be any profit. But if I purchase at 1 and then if I sell it 5, then the profit I will be getting 5 minus 1 is 4, right? Similarly, here I will be getting 3 minus 1, so I will be getting here 2 with these two, right? So I will be getting here the 2 gain, and here I will be getting the gain of 5 because 6 minus 1 is 5, and similarly I will be getting here 4 minus 1 is 3, right? So what is the maximum of all these things? The maximum profit is 5, right? Similarly, I need to traverse the whole array just to make sure that I did not get the maximum profit in the further iterations. Let's say this is 5, and right, so and 3 minus 5 will be minus 2, so this will not be the maximum. And similarly 6 minus 5 will be 1, and similarly 4 minus 5 will be the minus 1. So stock, this is how it works, right? Once we go forward, we can just for example, if I purchase any stock today, and if I am moving forward like day after tomorrow or tomorrow, I can just sell that stock, right? So that's why it's going forward only. So this is the problem context, and if we are able to understand the problem, then moving towards the solution part is we can simply just take any item of the array and just keep checking with each and every item in the array of the rest of the items in the array, and we can just keep tracking of maximum profit like we did for 7 and 1, right? And just keep checking what is the maximum profit, and that will be our answer. However, the complexity would be the n square complexity, but that should be the brute force. So let's start with the brute force first of all, and let's see how it goes. So what I mean to say, I will take the maximum profit, let's say it's 0, because I'm assuming that negative will not be the profit, right? Negative will be the loss itself, but not profit. So what I would do, I will just take price, each individual price. I will be checking the rest of the item array. So integer I equals to 0, and then price is dot length I plus plus, integer j equals to I plus 1, j is less than price is dot length j plus plus. And then if what I would do, like if price is j, if it is greater than price is I, right? So in this case what we see, like 1 is less than 7, so I mean there is no use to calculate the profit. The profit we can calculate if the consecutive price is greater than, right? So for example, in this case, like 1 and 5, so 1 is lesser than 5, so that we can calculate 5 minus 1 is 4, right? So that will be the profit. But in the negative case, like negative 6, this is not the profit, so we are not considering this negative case here. That's why I just mentioned prices j is greater than I, and if it is there, then just go ahead and keep calculating the maximum profit, right? So let's do this math.max, and this is max profit, and this would be my prices j minus prices I, right? And that's pretty much it, right? So and then what I would do, I will be just returning maximum profit. If I see the time complexity and space complexity here, so time complexity would be n square here, right? And space complexity will be the order of 1, because I am not taking any additional array or anything. So let's quickly check for the compilation error if there is any, and if there is not any, then let's go ahead and try to submit this one. So this took like runtime is 162 millisecond, right? So let's try to optimize a bit, and let's see if from n square complexity if we can optimize it to the linear complexity, that's the order of n, right? So to do that, we need to observe the pattern, like how did we solve this problem with the n square complexity. We took each and every element and we were just keep checking that element, like whatever the maximum, whatever the greater price, and once we get the greater price in the form of this code, then we were just keeping track of the maximum profit, right, by subtracting the greater price minus lower price, right? That's what we were doing. So if we check the pattern here, right, so this one, right, and then maximum profit was 6 minus 1, that is 5, right? So if we observe, like 1 is the lesser, I mean that is the least number, least stock price that we have been so far, right? There is nothing minimum than 1. So if we can find the minimum element and or minimum price of out of all these given prices, and then if we can keep checking what is the maximum profit we get by subtracting this minimum price, and if we are able to do that, then I think we should be good, right? So by seeing this pattern, so we can conclude this same thing. So let's, for example, let's first of all just check what is the minimum price. So let's say if I am taking some max value or something initially, right, and 7 is less than max value, then 7 will be my minimum price. Then further I encountered 1, right? So 1 will be my next minimum price. Then I move to the 5, and 5 is not lesser than 1, so 1 will still be the minimum price, right? But 5 and minus 1 I will get the 4, so 4 will be my maximum profit till here, right, till this boundary. And once I move forward, 3 minus 1, that is 2, so 4 will still be the profit, right? 4 will still be the profit. And then 6 minus 1, that is 5, and 5 is greater than 4, so next my next profit would be the 5, right, in the red color. So next maximum profit would be 5, and similarly like 4 minus 1 I would do, and that is 3, and 3 is still lesser than 5, so I will not consider 3. And I will just keep doing the same thing basically, and once I get this, then I can just rely on my minimum price, whatever the minimum price, that will always give me the maximum profit. So that's what the fact I can just use, and I can just optimize this algorithm further to the linear complexity. So let's quickly just uh, convert that into the one for loop, and maximum profit would still be 0. The only thing we need to take as the minimum price, so let's take minimum price here, and as we discussed, let's take this as a maximum value, so that at least we can have some our initial minimum price. So if this price is I, if it is less than min price, right, if it is less than min price, then what we are going to do, we will be saying this minimum price equals to price is I, right? And if it is not lesser than, then the next step that it was there, like for example the next case will be 5, right? 5 is not lesser than, so what we are doing, we are calculating the maximum profit. So we can do the same thing here as well. So max profit equals to math dot max would be max profit, comma uh, max profit would be prices, so current price minus min price, right? That's what we were doing in our whiteboarding session, right? So current price means 5 and minus 1, that is 4, that's what, and similarly 3 minus 1, that is 2. That's what we were just keep doing to calculate the maximum profit. And I think that should be sufficient. And if the complexity we reduce to the linear complexity here, and space complexity would still be order of 1. Let's quickly check how it's going, and we missed the semicolon. Let's try to correct that syntax error, and this is working fine. Let's try to submit and let's see if there is an improvement. So yeah, runtime moved to the from 162 millisecond to 1 millisecond. So I think this is a significant improvement in the runtime complexity, and of course we cut all the unnecessary transactions that we were doing during O n square complexity. So I think this is helpful. Have a good one. Thank you. Bye.